CO2 is one of the most significant of the greenhouse gases. It is pumped into the atmosphere when we burn fossil fuels to feed our energy-hungry lifestyles. But what if this carbon dioxide could be isolated, chemically or physically, from the atmosphere? This approach to dealing with carbon emissions is called carbon sequestration, and there are many new and developing ways to accomplish it. One proposed method is to dissolve produced CO2 in the sea. When injected deep into the water where the pressure is high, CO2 dissolves, largely as molecular CO2, into the water. This method, however, has major drawbacks. It is possible that high CO2 concentrations in the deep sea could affect bacteria, causing far-reaching changes in the chemistry and energy balance of the oceans. It could also be physically isolated by injecting it as a supercritical fluid into expired oil wells under the sea or the land. Another proposed method is to store the CO2 underground. CO2 can be injected as gas to coal seams. The CO2 adsorbs to the coal surface, and large quantities of it can be stored in this way. The carbon dioxide displaces methane on the coal's surface, and this must be drawn off from the seam and itself burned. Deeper underground, the CO2 can be sequestered into deep saline aquifers, areas of porous rock bearing salt water. Coming back above ground, we consider that our solutions so far have been largely physical, but what of a process that has been chemically fixing carbon for millions and millions of years? The process is of course photosynthesis, and algae do it exceptionally well in certain circumstances. Our plan is to create conditions whereby large concentrations of CO2 fuel the algae's growth. Unconverted heat will be transferred from the plant to warm the algae tanks to an optimum. They will be in a growth medium that meets all of their requirements and will be positioned to take in as much sunlight as possible. The produced CO2 will be piped through beds of algae, which will produce both an oil that can be used as a biodiesel to offset diesel burning and an organic residue. This can be used as a fertilizer or treated to remove its nutrients and then stored. The uncombined CO2 will be separated from the oxygen and other gases passing through the algae by use of a semi-permeable membrane prison system. All of the CO2 remaining will be geologically sequestered in expired oil wells, coal seams and saline aquifers, providing a sequestration of 100% of the produced CO2. We've estimated that with 4 kilometers squared of algae beds, 50% of the CO2 from the plant could be converted, leaving 2,100 tons per day to be sequestered geologically. We feel that our solution is both innovative and well considered, and think that as this technology is improved, efficiency and yield could be increased.